minutes. All right, can you see my screen? All right.
Yes, we can.
So, yeah, so the idea today is to find a common ground between the CX practice and artificial intelligence. And the motivation for this is a statement that Satya added to his book, saying that we need to build a deeper empathy for our customers and their unarticulated and unmet needs. It was time to hit refresh. So in his book, he already says that we need to create that empathy, right, with customers. And the challenge was, well, I want to understand their unarticulated needs, their unmet needs. Traditionally, we use satisfaction surveys, and whoever participates in the satisfaction surveys get heard and get helped if they're going through challenges. But what about the customers that do not participate in surveys? They might still have needs that need to be met, but they're just not articulating. So we want to use AI on top of the CX practice to find those unarticulated needs that the customers might have and be proactive in helping them. So luckily, nowadays, machine learning is literally a piece of cake. It's super easy. And I'm going to show you how to create machine learning models just in minutes without writing any piece of code, okay? So there are two paths for data science. You can take the traditional data science path. And when we say traditional, it's something from like 3 years ago. That's already traditional in the machine learning area, right? It requires deep understanding of mathematics. It's highly specialized. You have to write code. However, it can be super powerful. You can create very specific models to solve very specific problems. The new way to do data science is to use auto machine learning or auto ML. These are tools that takes what in the brain of these data scientists, squeeze them out and implement in code. There are some of these tools that I'm going to show you today that what they say is that they use AI to do AI. All right, so they learn from your data and create a genetic algorithm to evolve your model and make it learn. So the two paths, I think, are the best way to illustrate that is baking a cake, like I mentioned in the previous slide. You can bake a cake today in two different ways. You can start everything from scratch with the flour, with the eggs, and make the whole mess the traditional way. Or you can go to the supermarket, or even better, Amazon.com, and order a cake mix. And in just a few minutes, you have a cake. Now, if I bake a cake using this box here and offer to my grandmother, she is going to complain. She's going to be very mad at me because I'm not doing things right. I'm not doing things in the traditional way. However, she doesn't realize that these cake mixes have evolved and they're delicious now. You can make cakes very quickly, or you can spend your whole afternoon in trial and error baking a cake, right? But if you ask a traditionalist data scientist, they are going to prefer to do everything by hand, just like my grandmother. So don't be like my grandmother. You can use the more modern tools instead. So before we jump into the details, I just wanted to give a little bit of the process of machine learning. And this is the process that I have immersed myself for quite some time, which is, it always starts with data, right? You have to first understand the problem. What is the problem that we are really trying to solve, and what are the goals? What is the contract that I have with the company or with the leadership or my team on what we are trying to solve. Then it's about getting and preparing data. And the getting and preparing data is what Daniel is going to be talking about today, right? Once you get that data, you have to understand it, then you have to massage it and clean it. And then once you have a good understanding of the data, you have to select the algorithms that you want to use. Depending on the algorithms, you have to do what we call the feature engineering. When something happens, the customer might be satisfied. When something else happens, they might be dissatisfied. But when these two things happen at the same time, what could happen? Can it magnify the satisfaction or magnify the dissatisfaction? So the interaction of features in the model or the experiences in the journey of the customer with your company can be important. And then we split the data into a training set and a test set. I want to show you what that means in the next slide. And then you start training the model. And what is super important, you have to tune the hyperparameters. The hyperparameters are like the knobs in a big soundboard that the sound engineers have. They have to tweak the volume of the microphone, the drums, the guitars, etc., until it sounds great. And this can be a tedious process, can take a long time. And if you make the wrong configuration, you have to start from scratch. So this is something that is kind of in the core of the data science exercise that takes a lot of time, but it's also automated by these tools that I'm going to show. And finally, you use the test data to evaluate the performance of that model. For example, the accuracy is 75%. But what we agreed in the beginning was accuracy of 80%. So then I have to repeat this process. Maybe I go back to step number 8 and tune the hyperparameters again, try again, or then I go back to step 6 and do a different feature engineering technique, or select another algorithm in step 5, or even go back to step 1 and renegotiate the goal for that project. It could be that 80% is impossible. Maybe 75% is good enough, right? So that there are some situations that we have to simply, go back and redefine the process. Now, for data collection, this is an area that data scientists, twist their noses. They don't like it because it takes a lot of time. In the project that I'm going to talk about, I spent about 3 years collecting data at Microsoft and understanding the data, cleaning, massaging, connecting the data, etc. And data is nothing more than a mathematical representation of the world. For example, you have the iris data set. Everybody that is involved with data science, machine learning, have seen the iris data set. So I would be amiss if I didn't mention that the iris data set is like learning to play the guitar and never learning Stairway to Heaven, right? That's a must. So how do you transform nature, right, real life, into something that can be represented by numbers? In this case, we are measuring the petals, the sepals of the flower, and these proportions here allow us to differentiate between the versicolor, setosa, or virginica varieties, right? So we collect this data and we know the species. Then we separate this data set into the training data set. This is what I'm going to use to train the machine learning model. And this test data set is a small number of rows that is enough to measure the performance of this model that I created. I already know the truth, right? This is versicolor. So if the model predicts that is a versicolor, good. If it predicts that is a setosa, then it's a mistake, right? And I repeat this to the data set and calculate, for example, the percentage that the model is right. And if that percentage is good enough, great. Otherwise, I have to repeat the process, right? So for every data set that you collect, the right way to do this modeling is separate a test data set that you don't use to train the model to evaluate the model performance, okay? So if you're talking about customer experience, how do you collect data, right? And that's where Daniel starts his part.
Thank you, Fabio. Thank you. So there was a study done several years ago around customer experience, and they went out and surveyed and asked business leaders, executives about the experience that they delivered to their customers. Did they believe it was a good experience? And of course, a very high percentage, 80% of them said absolutely it's a great experience. But then when they went out and talked to and surveyed their actual customers and asked them if their company was delivering a great experience, only 8% said it was great. So there's our opportunity here with customer understanding and experience management and designing great experiences is figuring out a way to close this 72-point perception gap, right? Now, why don't we go to the next slide, Fabio? So, we talk about, the data associated with, customer experience, and it's data around customer perception, it's data around customer behaviors, it's an understanding of personas and individuals, who they are and what they're trying to accomplish. And one of the tools that we use very commonly in Microsoft, and I'm sure most of you, if you're CX practitioners, you've used journey mapping and personas before. And all that really is just it's a visual representation of a customer's and individual's end-to-end experience, and it takes the soft and squishy concepts like human emotion and allows us to put some structure on it so that we can better understand it and then ultimately manage it, right? So we're going to take these things like what they want, what they're thinking, how they're feeling, what they're doing, and we'll start to understand how they're doing that today or how they're feeling today, and how do we want them to feel, after we design and curate the ideal experience for them. So go to the next slide, Fabio. So, we should know customer experience, it's simple, but delivering it is hard, right? So, we have these individuals and we don't design experiences for individuals because that typically costs a lot. There's a lot of investment required to do that. But we don't design one size fits all experiences because that would lack empathy. And this is all about an exercise in empathy, as Fabio talked about in the beginning, right? So we take these personas, groups of individuals with common characteristics, and it's important that we spend some time and think through what are the characteristics that matter, and some of this we'll talk about in another slide. So they go through this journey, and this is a typical Microsoft commercial customer journey: learn, try, buy, deploy, use, value. And they go through this, and they have wants and needs that they're satisfying throughout each of those stages. There's touch points that they're interacting with, and then they perceive that experience as useful, easy, enjoyable. So this is the emotional aspect. How much value they got out of it, that's the useful. Effort, ease, how much effort they put into it. And enjoyable is the emotional response. And this is really related to like the brand experience, right? So when you think about, how you feel about, doing business, like Microsoft's brand, we're about productivity, like our office tools are about individual productivity. Our brand represents, sustainability. So, we have a commitment to go carbon neutral. Those are things that make people feel good about interacting with that company, right? So they formulate these perceptions based on these experiences, and that drives them to their behaviors to do something else, right? So, what we really want them to do is rebuy. We really like them to increase their business with us as our customers, but what would be fantastic, and this is where we get the viral flywheel growth effect, is recommend, right? So this is where the viral word of mouth really lowers the cost for a company's cost of customer acquisition, right? So you don't necessarily have to market because everybody's just talking about it, right? And that's like the ideal experience that we're trying to curate here. Now, our challenge here is, as we all know as CX practitioners, is that this experience is whatever they think it is. And that's the difficulty in trying to measure it and predict it and to design good experiences and to make the good decisions around where we need to make investments to deliver great experience. So let's go to the next slide, Fabio. And I think there was another bit of research that I wanted to mention here. That was actually just published this week, the 2021 State of Digital Transformation from Altimeter. It's a very interesting bit of research that talks about companies' digital transformation efforts. And by the way, this should be very exciting for all of us CX practitioners that are out there, maybe looking for work and looking to get into big business or into business. Is that most top performing companies, the majority of top performing companies are using AI and ML to help them better understand customer journeys. So there's a really interesting sweet spot of these two disciplines. Is there a question? Okay, maybe somebody's not on mute. All right, so look, so we use these journey maps, and we start out just formulating internal hypotheses. So we gather a bunch of SMEs and we start to map out these journeys and personas and what we think. And these are a couple of examples of some journey maps that we've used inside of Microsoft to understand this is a sales productivity journey using Microsoft CRM tools Dynamics, right? And here they go through this journey, and there's some details here, on these slides here. But the point is that we formulate these hypotheses, and that allows us to put some structure around the perception data that we need to go and gather. So where are the moments of truth along this journey? Where do we think there's the biggest gap in our ability to deliver at those moments of truth? And then we can start to go and collect, obviously the perception data through surveys, qualitative research plus quant research to do that validation, and that we can use that to inform our models. And then also we can go out and get the behavior data and the business performance data at those particular points too, and really use that to help inform our analysis and build that customer understanding, right? So next slide. So this is, really some details around how we do this at Microsoft. So, even before we start to get into by the way, we advocate for a collaborative workshop-based approach to building our journey maps. And such an organization as large as Microsoft, not one, team owns the end-to-end experience, right? There's lots of different teams that need to come together. And, it's important that we spend the time to build that understanding across various teams. So before we get into that workshop, we spend some time up front, just, as this, CX practitioner, my role is like a strategist in scoping and understanding what are the signals that we're receiving that's giving us an indication that the experience is not going well, or where we might have gaps, or where we can improve, right? And it could be that we're, losing share to competition, or we're getting support cases coming in from our contact centers. And we start to build that out and really understand who we need to, who the right SMEs we need to bring in. Make sure that we have the right sponsorship from leadership to make sure that we're getting the right priority and investment that we need to ultimately deliver on the recommendations and findings that come out of this work. And then we get to that workshop, and then after that, we have that internal hypothesis that we can go out and then validate through qualitative type modalities like one-on-one interviews, focus groups, and then even go further. We want to get a really broad reach, across. We have millions of customers around the world, right? We want to get a representative sample of those customers that really get that understanding about, how do we think about these hypotheses and get the right amount of the data sets that we need through quantitative research. So, Fabio, I'm going to toss it back to you to sort of bring this all together and how we're using AI machine learning here.
All right, so here is the project that I started almost 5 years ago. First was understanding these customer journeys, right? And the nature of Microsoft is super complex because the same customer can be on multiple journeys at the same time. If you think only about the Azure, Office 365, Dynamics 365 clouds, the same customer can be on these very three journeys at the same time. Some for example, this team has 3 members, some participate in one project, some participate in other projects, so they don't have also the entire view of their experience, right? Then we have all the touch points, all the metrics associated with them, right, that we can collect. And this is what really took time. I went around the campus here in Redmond, knocking on people's door and say, hey, give me data, right? And we started collecting that experience data from the different touch points. Went to technical support, give me your technical support case data, sales, opportunity data, operations, contracts, even just a CRM information, what type of classification we have for that customer. We collect all of that, then we collect the voice of the customer. We have, for this type of customers, we have a quarterly survey that goes out and asks, what is your overall satisfaction with Microsoft? And that's the only question that I need from the entire survey. What is your overall satisfaction with Microsoft? Then train a machine learning model to recognize patterns in the data. So what it means is I take the responses from each one of these customers. They're saying not satisfied, satisfied, and I connect all this data point that I identify through the journey maps into their records. So this customer said not satisfied, and these are their data. These other customers said not satisfied, and these are the values for each one of these data points. When I feed this into the machine learning model, it will learn all the combinations, all the patterns in the data that makes customers happy versus unhappy. And then I apply this model to my entire customer list. I have the data for all of them, right? And when I run the model, it will give me a number, a probability of the customer being happy or unhappy, right? That I can define how we're going to handle that probability. For example, this customer is 97% likely to be happy, great, while this one is only 8%, right? So I can tell the accounting for this customer here that they could do something about it. And then what we call here is a customer experience risk. It's a number that can indicate if the customer is going through or about to go through a bad experience that we could take a proactive stance. So this is what the model actually looks like. I collected data, like I mentioned, from what we call the know your customer, where they are, what is the geography, industry. Do we have an account plan so we understand the customer better? What is the type of relationship, the transactions that we have with them? Do they participate in events? In the purchase experience, what is the opportunity win ratio, meaning how many opportunities are we winning that company versus how many opportunities we're losing, and so on. And we use even external factors like competition, COVID infection in their local markets, and see how we are responding to those events is helping the customer experience or not. So this left side of the diagram is data that I have for every customer, okay? The surveys we get only for customers that actually participate, let's say 20% of the customers, right? And what about the other 80%? So we feed this into the model and we will calculate the likelihood of customer being satisfied with their experience, even if they haven't participated in the survey, because the model learned the patterns here in the data. right? So the model is going to give me two things. One, what is the likelihood of the customer being unhappy with the experience? And two, which one of these features are important for the customer? I'm not going to be able to show you today, but what you can do is for each customer, you can tell what piece of experience it was most important for the model to give that outcome. So for Walmart, it could be end of support. For Starbucks, it could be Microsoft financing and so on. So we can tailor the customer experience at individual customer level, right? You can make a hyper personalized approach. So if you have consumers, for example, you can understand exactly what moves that consumer, and you can advertise, you can help them, you can greet them in a different way, right? So how do you do that? How do you get this data and transform into machine learning model? Today, we have many options out there that exist. Microsoft, we have our own Azure machine learning. You create diagrams like this, connecting blocks that has different functions, different models, and you create your own model. There is also exploratory. It is a super easy to use tool that you can do all sorts of analysis. I'm going to be using this today. We have driverless AI. This is the tool that I actually use to create my models. Orange, I'm going to talk about this today. In the morning, we had a similar talk, and we talk about Newton. Newton is a new entrant in the market. They have a new model that is super simple to use. But how do I pick the best tool? One aspect is the cost. Here we have a moderate cost, and just to understand this, these applications are in the cloud. And when you have a cloud application, sometimes you have to pay for the application itself, but you also have to pay for the hosting of that application, right? The compute power behind it, you have to pay. Some of these can be installed in your own computer. So if you have a powerful computer, things are going to happen fast. If you have a slow computer, it's going to run slowly. However, on the cloud, you can create a machine with 256 processors with 2 terabytes of memory, and get a big machine and run your models. So each one of these options here have their pros and cons. Exploratory is super inexpensive. You can pay out of your pocket, no big deal, and you're going to see a little bit more. Driverless AI is super expensive. It costs a lot of money, plus you need a really big machine in order to make this happen. Orange, which I'm also going to show today, is completely free. You can just go to orangedatamining.com, download the tool, run everything by yourself. And with the recording here, you can follow the steps and repeat whatever I show you later at home. And we have Newton. It is not as expensive as the other options. And the other point to consider is how easy to use these tools are. Microsoft offering is more technical. It requires more knowledge of the data science to actually use it. Exploratory is super easy. It is intuitive, but it requires some knowledge of so you can find at least you can understand the menu options that you need to select. Driverless AI is kind of middle of the road. Orange is also easy to use, and Newton you need only half a brain to use it. You just load the data, click run, and it does everything. Okay. So I'm going to talk about exploratory, and I'm going to talk about Orange today, okay? In Orange, I'm going to show you how to solve this problem, but to make it more visual, I'm going to use something a little bit different, but just to show the power of these tools, you can create an automatic image diagnostic. You can take an X-ray and tell in the X-ray if the patient has pneumonia, for example, or if it is a normal X-ray. There is a new data source available in Kaggle with COVID. So you can even detect COVID by just looking at X-rays. But for me, I cannot tell the difference between the top image or the new, the bottom image. So I'm going to show you something easier to understand. So let's jump into the demos. Before I start, any question?
Yeah.
Quality. Driverless AI is probably the best one, but it costs about $80,000 per year per seat, plus the cost of the equipment to run it, which might cost $1,000 a month. So it's pretty expensive. However, you'll get results that you cannot get even with a grandmaster. So let me show you some examples. Suppose that you have an employee survey, right? This is what it would look like. You have a 10-point scale. The main question here is passionate about the current work, and then other questions like considering the job important, over time, satisfied with the amount of work, etc. So we have a number of questions, and then if it is a male or female, and the age group. Okay, typical survey. You can load this data from different sources, a file, a server, anything. If I go to summary, it will show automatically the distribution of the data. I can see if there is any missing data, which in case of surveys is pretty common. People skip questions that can introduce some problems. But here, as you can see here, the NA is all 0%. So everything is clean, everything is perfect. There are a couple of things that I can do here. One is to create an analysis, a driver analysis. You probably have heard about that. So let's select a linear regression. And my main variable is passionate.
Hey Fabio, sorry to interrupt. I think it would be good to kind of explain like what driver analysis is and what you're trying to get from the regression model before you show it. Just
sure. So the driver analysis is this is more of a statistical model. It's not really a machine learning model yet. But what it does is it shows the correlations between the questions and the main questions that you have in the survey. So you know which question you need to improve in order to improve the overall satisfaction question. Okay, so if you have all this data, the first thing that you want to do, okay, so what about the employee experience do I need to improve? Okay, and this is what this model can help tell you. Okay, so there are two things in a model. One is the target variable. The target variable is what I'm trying to predict or what I'm trying to improve. I'm trying to improve how passionate our employees are about the company. And all the other variables are things that I can understand what if it's driving. Is it, should I look at help understand the importance of their work? Is it overtime a problem, etc. So this is what I'm trying to figure out. Right, so I just set up very quickly like this, click run. And it is training the model, and it's going to give me the importance of each one of these variables to the employee experience. There we go. So what is important here is actually this importance chart, right? So the consider current job is important is extremely important for the employee experience here. And the second one is if the boss gives appropriate feedback. So the most important thing to drive the employee passion is how important they think their work really is, right? So this is an insight that it would take a lot of time tabulating this data, etc., or hiring an external analytics company to do this for you, and you can do just in a few seconds, okay? The other thing that you might want to do is suppose that it's really hard to get the return rates in the survey that you want. People are not really participating, and they have many different questions. This is just an example, but maybe I have 50 questions in my survey. Do I really need these 50 questions? One thing that you can do is create another model here. And in this one, what I'm going to do is I'm going to do this principal component analysis. What the principal component analysis is, imagine that you have, height versus age. And here in the middle, you have the correlation of these two variables, right? Imagine that I have a third element here, which is, for example, gender. Then I have a three-dimensional model. If I have four, then I cannot visualize that anymore, right? Those are 4 dimensions. In this question here, I mean, in this survey, I have 9 dimensions. Imagine that these questions are generating a space of 9 dimensions. What this PCA analysis is going to do is flatten all those dimensions into a piece of paper. It's like you get a machine and you get the plan on paper, right? It's a projection. So the variable columns that I want to use, and by the way, this works only with numeric variables. I cannot use these alphanumeric variables. But what this does is, when I say that something is orthogonal to another, it means that one thing doesn't impact the other. So, for example, if I have something like this, the more I move into the X, nothing happens with the Y, right? Because they are orthogonal. Now, if I have an angle like this, what it means is that if I move around this dimension, there is kind of a shadow, if you will, in this other dimension. So these 2 dimensions are kind of what we call collinear, right? So what this analysis allows us to do is to see if these dimensions are separated from one another or if they are collinear. In a survey, you want the questions not to be collinear. What it means to be collinear is that the questions are essentially synonyms to one another. So consider the job important and passionate about the current work. These are collinear questions. Or current overtime level is acceptable and satisfied with the amount of work. They are also very close to one another. So what this chart tells you is that I can get rid of one of these 2 questions and then one of these 2 questions. So now I have fewer questions in my survey and I still have the necessary information to do my job. Okay, so this is, it might sound a little crazy, but it is what we do here to select the questions that should be in the survey. So we give the respondent a better experience as well. Another example here is, imagine that I have customers. I have a customer base in a country, and by area code, I have their economic indexes, and I want to figure out where I should have a marketing campaign. So I want to group these customers in a way that I optimize my budget. So it's a customer segmentation exercise, okay? So I have the zip code, and then I have the socioeconomic indexes. If I go to analytics, now what I'm going to do is a k-means clustering. Clustering means that I'm looking at customers that are near each other, but near each other in terms of those dimensions, the indexes, customers that have similar indexes, and group them together. Okay, so what I'm going to do is create, use those 4 indexes to calculate which customers most resemble, or zip codes that most resemble one another, right? So I'll click OK, and let's run it. By default, I think it's going to try to find 3 clusters, 3 groups of customers. And it's also going to put here in this chart. So if you see here, it found 3 groups of customers, this green, blue, and yellow. Just looking at here, well, what does this mean, right? So if you see these 3 economic indexes, the way that we understand here is that these are kind of axes going out of the center. So data points, which are zip codes that are towards this, is that they have higher education and occupation indexes. Customers that are farther on this axis, they have socioeconomic advantage and disadvantage. Socioeconomic disadvantage this way, and the index of economic resources that other way. What implies is that customers that are on the other side have lower. So if you look at these 3 groups, we have high, median, and high socioeconomic capability, impact, purchasing power, whatever you want to call it, right? So when you do that, you let me just you use the graphical representation to understand it, and then you can add this as a step. Okay, so I'm going to use k-means clustering. I'm going to use indexes. So unfortunately, I don't have time to explain the tool, but I just want to show what you can do with it. So now I separated graphically, I created cluster 1, 2, and 3 that I understand that cluster 2 means high power, purchasing power, 1 is medium, and 3 is low, right? So now what I did here, I added a column to my table with the cluster, right? So this zip code belongs to cluster 2. This zip code belongs to 1. But still, it's impossible to tell if this is reasonable or not. Luckily, I have these are area codes or postcodes in Australia, and I have their latitude and longitude. What I can do here is to join with the other table. So I want to join with the postcodes. I want to connect the postcode here with the postcode here, click run. And now I have these 2 tables combined. I have the zip code, the cluster, and I have the longitude and latitude. And what I can do here now is to make it more visible of what you can do here is I select a map where I'm going to show, longitude, latitude, and color by cluster. So now I can see that on a map, or if I can zoom it, I see that, the clusters 2, remember the cluster 2 is the clusters with more power, purchasing power, are near the big cities in Australia. So for an Australian, this will make complete sense. This will be, people in New York, in Seattle, Portland, etc., that could be my target. So this is a way to segment customers in a super easy way and visualize that data. Now, let me show you Orange. And I'm glad that you are recording this because this is going to be super quick as well. Now, this tool is, I think, being free is just impossible. This is super powerful. What I'm going to do is, remember the X-rays. I can differentiate X-rays there for sick individuals or healthy individuals. But to make things a little bit easier to understand, what I'm going to do is create a different model. I have here 500 pictures of cats. And a cat in all the different poses, positions, on somebody's laps, in a cage, right? All different poses. Then I have 500 pictures of dogs. Again, the same thing. The dogs are in all different positions, right? And this is what it looks like. Now, the way to organize the data in image format to load into a model is simply by adding them to folders. So the folder name is going to be my label, what I'm trying to predict. Right? I'm trying to predict if this a picture is a picture of a cat or the picture of a dog. And the folder name is the label. So the name of the file, right? So if you go to cat, you're going to have all the different files are just numbers, right? They're not meaningful, but the folder name is. And my test data set is this. This is my dog, Ella. She desperately needs a haircut. And my dog, Freddie, is here. Okay, so I'm using their pictures to predict if they are cats or dogs. Well, let's see if that works. So the first step, and by the way, the Orange application is a visual programming application. You simply drag widgets to a canvas, and you interact with the widgets and interconnect them. So this is a widget to load pictures. So I select the folder. So I want to select the training data set. I select the root folder and the folders with cat, who have the label cat, dog, label dog. Select the file, the folder. It's going to load the 1,000 pictures, 500 of each. By the way, this data set has 12,000 pictures of cats, 12,000 pictures of dogs, but for time's sake, I'm loading only about 1,000. And if you connect here to an image viewer, I simply extend this line here, and I click here, I see the pictures. I have cats with the label cat coming from the folder name, and dogs coming from the folder dog. So you can imagine that I could have put in here images of those x-rays, sick, healthy, or parts that coming out of assembly line, good or bad, right? And I'll train a computer vision model to differentiate one for the other, okay? So the first step here is to use this tool here called image embedding. Image embedding will do exactly what I showed with the iris data set. We'll find numbers to represent that picture, right? And we collected 4 numbers for each picture in that data set. Here, what it's going to do is it's going to run those pictures through a neural network, and we'll find 2,048 numbers that represent those pictures. So while it's calculating, I'm going to add here a data table. I think I have to wait until it finishes. There we go. Okay, so first let's take a look at what the data table will show with the raw data. It's just the category, the image name, the size of the picture, the dimensions of the pictures. So as you can see, it's all different sizes, different dimensions, 80 by 120, 800 by 600. They are all different sizes. In order to run a machine learning model, you know, these models like everything to be consistent. So if I disconnect this line and connect my image embedding to this data table, this is what I'm going to see. It added 2,048 numbers that associate with each one of these pictures. And this has nothing to do with the pixel colors or anything like that. Those are vectors that was created by that machine learning model. So now I'm ready with my data. I created features out of those pictures. I go back to, I go to my model. And now that I have the numbers to represent the pictures, I can create, for example, a random forest model. What the random forest.
Hey Fabio, I'm gonna interrupt you. I think maybe just a little bit on the embedding, just to say what embedding is, because you'll probably, if folks start searching for embedding on the internet, they'll get lost.
Okay.
You showed, I think, the simplest representation of the most concrete, representation of an embedding from an image. So maybe we just step back, because that's also used in natural language understanding. It gets used in multiple concepts. So just for the rest of us, what is an embedding?
Yeah, embedding is a technique to transform something that is unstructured in something structured. Let's put it this way. How do you transform a picture into something that I can process in a machine learning model? This can be done with documents, with words. It can be done with images, pixels, etc. So it's just a transformation, let's put it this way. And this is where neural networks are typically applied. Neural networks can be used to predict things, but in many cases, they are used to transform data from different modes into numeric mode, so we can feed into more traditional models, right? So now the random forest will look at the patterns in those numbers and associate with cats and associate with dogs, okay? Let me disconnect this guy here and let me connect to the output of the random forest to see what's going on. Oh, actually, I cannot connect here. I need to first, I have to, I created the model, then I need to predict with the output of this model, right? So what I'm going to do here is load my test data set. I'll use another import widget. And this time, instead of the training data set, I'm going to use the test data set, right? Where I have the pictures of Freddie and Ella. So I'm going to disconnect this data here, connect it here, so I can see what it brought. See, we have the different pictures here. I have Ella, I have Freddie, I have a random internet cat, right? And these are the original file names. What I need here is to predict if these are cats or dogs. So I'm going to leave it right here. And I need to push this data through the same process that I did here with the embedding step. So I'm going to add another embedding widget here, push the data through the embedding. So now the data is prepared, and I can now feed into the model to make the predictions. And how you do that is, couldn't be better, but it's a crystal ball. You connect the model that you created and the data that you want to predict. Okay, so now I have my predictions made.
Fabio, one more question. One
Sure.
more question. Just we kind of slow down a little bit, because this is really powerful. It really is. But I just want to kind of slow down a little bit here.
Sure.
What is random forest, and why did you pick random forest?
It could be any model here. I picked random forest because you have a high number of features. I have 2048. And normally for a high dimensional project model like this data set, a random forest is more indicated. This comes more with experience. I could have tried other things. By trial and error, I can change. I can delete the random forest and pick a tree model, or gradient boosting vector machine, or whatever, right?
Yeah.
So that's why I picked that.
So the nice thing though is, I'm just gonna do is, if you're doing this in Orange, if you get access to it, don't worry about picking a model randomly.
Yeah.
And what you do over time is you test the performance of multiple models. A lot of times you actually have a machine learning harness running. That's like comparing the performance of these models. And it's not just one model. You know, you pick multiple models and you start to kind of compare the performance. Mm-hmm. And you could do this in, here through Orange as well. So if you do it, don't be shy. Test these models, compare their performance. And that's what data scientists do as well. And they do it all the time.
Now, so let's check if the predictions make sense or not. All right, so these are this was the input, and this is the output. Cat, dog, 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 cat, cat, dog, and dog. There we go. If you have pictures of your own pets, you can even post here on the chat window, and we can predict if your cat is really a cat or it's an animal disguised as a cat, I guess, right? But you mentioned, Munir, working with text. Let me show you that as well. So here's the deal. You can have the data already, emails, for example, or customer letters or whatever, and you want to analyze that text. Here I have some data sources from within Orange that I can use. I can look at New York Times, Guardian, and Twitter, Wikipedia, etc., and pull the data automatically for me. So here in the Guardian, I can, for example, here I can enter the name of a company, for example, Facebook or anything else, and select a date range. So for the last few days, I want to pull the headlines and the content and click search. Okay, now let's take a look at what is the data that we got from the Guardian. All right, so here we go. Here is the section, if it's technology, opinion, etc., the headline, the content, if there's additional text, the language, etc., even the URL and word count, right? So this is the data that came from the Guardian, and this content here, for example, here has 1,500 words. So this is long format text, okay? And then we close a few windows here. Now, what can I do with this? One immediate thing that you might think is, are these articles about Facebook of a positive or negative nature, right? So I can come here to my text mining and do sentiment analysis.
This is awesome. This is free.
Yeah, and it's free. So I connect here, it's going to do the sentiment analysis. Come on.
And you're, Fabio, you're running on your local machine?
Yes.
Okay.
A notebook. Okay. So now let me disconnect here and connect here. All right. So this is the same data, and it added 4 columns. The positive index, negative, neutral, and the compound. The compound is, looking at these numbers, what is the polarity, if you will, of the sentiment in that article? Is it negative or positive? And the closer to 1 or -1, you have like a perfect match. So this article is almost 100% negative to Facebook. This one is almost 100% positive to Facebook, right? And if I open here a little bit, it's talking about the whistleblower, blah, blah, blah. This one that is see which one was positive. This one is positive, is also talking about the whistleblower, but probably in a more positive light. So here I can sort these articles by polarity, right? And look at the articles that are most negative or the articles that are most positive, or I can calculate the percentage of positive versus negative. So then I have and even over time, so I can see if the sentiment in the media, for example, is changing for my brand, right? And here it took just a few clicks. A couple of years ago, I would have spent a week writing Python code in order to do that. Okay. One thing that I didn't show is that when you double click these widgets, you have a bunch of different options. So for example, the sentiment analysis has different algorithms or models here. So the model that I'm selecting here is called Vader, but you can have the Liuhu, we have multilingual sentiment. So if you have a text in German, you can select here the language, and you do sentiment analysis in Korean, whatever, right? The cool thing about this model Vader is that it identifies emoji. So if you have a wink wink, if you have a smiley face, a frowny face, it detects the sentiment in the emoji, right? And adds that to the calculation. And here you can, as you can imagine, you can do any number of things. And like you mentioned before, I can go to the model again, instead of creating a random forest for this model here, I can compare to a single tree. So I connect here, it will calculate the tree model. I'll disconnect this from this model and connect to this model instead. Okay, so now I have two trained models, one tree model and one random forest. Let's take a look at the performance of this tree model. Dog, cat, 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 dog, dog, dog. Not bad. But you know, and then you can decide if you want to do a tree model or you want to do a random forest. The pros and cons is that a tree model is probably a lot faster to run. So if you are embedding this into the firmware of a camera, right, then you probably want to find the smallest model that does the job, right, that consumes the least power, least processor, etc. There is even something really cool here, if I can find it, is tree viewer, which shows what in the picture it is deciding that is a dog or a cat. This is meaningless for us, right? But if you have a more complex data like that survey data, you can see a tree that goes, if the customer, the employee answer low in this question, then go to this side. If it answer high in this other question, go to the other direction until you have a tree describing the model, which can be also useful. So you can visualize if you know, the model is making business sense, right? So there are some tools here that you can visualize the data, visualize the model, and see if the model is making business sense.
Which comes back to a really important point. Maybe Fabio, you can talk about the whole explain. I know we don't have time. Maybe just real quick on explainability, right? Understanding how the model performs.
Yes.
And just a little bit on that one.
Yeah, and this is the super useful tool that I use internally at Microsoft, because in that model that I described that we have to predict customer satisfaction, we have 800 data points. If I tell an account manager, your customer is unhappy, what can they do, right? Well, we have a list of 800 different things that you could try. Not very useful. So what this explainability or interpretation routines do is, the tree model, right, is easy to understand. You look at the tree model and you see how the model is making decisions, so you know what is important, what is not, right? Now, in a random forest, it becomes a black box. You don't know what's inside. So what they do is you train a model, then you attach another model on top of your model, right, that tweaks the inputs and see what is coming out in the output. So if I change this value, only this value, is this going up or going down? Then I change this model, this input again, and it's going to go up or down. And so it does all the combination and tell you which input is causing the most effect in the output. Okay, and with this, you can tell in general what is going on, what are the things that happen in the customer experience, for example, that most affect their experience. And if you are go one step further, this allows you to identify for each prediction what were the features or the experiences that most impacted that individual prediction, right? So if I have a line for Starbucks, a line for Walmart, a line for Costco, right? I am able to tell what among all these variables are important for Walmart or important for Starbucks, and they could be completely different, right? At Microsoft, Starbucks and Walmart are in the same segment, right? We segment them the same, but their experience is very different. One is retail, both are retail, by the way, but the Walmart business is very different than the Starbucks, right? So I can tell and give the account manager, these are the features that are, and I cannot show you, I wish I could, but it's like the red team and the green team in a tug of war, right? This team is pulling the customer to the green zone. This other team is pulling the customer to the red zone. And you have to watch, because if these players here become stronger, they can pull your customer to the red zone. So you have to, maintain the green and try to minimize the red, right? So it tells you, and depending on who looks at that, they can take action on some of the customer experience. So for example, if I am in charge of technical support for Walmart, and I see that technical support is what has some issues, I can go and correct. But if I'm in sales, I don't have any influence in technical support, but I can work on something more related to my area of influence, right? So this goes to the entire account team, and they can take the necessary actions within those areas, right? In this type of exercise, knowing what the features are that are most important is not that meaningful. But in this here, sentiment analysis, it could be. So you can select what are the keywords that are most important here, right? And those are, it's kind of a special case in this process, which is the topic modeling. I can simply connect this other model here and connect to this model. It is going to perform all that I mentioned, the embedding, right? Is going to do something similar to what they did, what the model did with the pictures here, the image embedding. It will calculate the topics instead. So you can see what are the keywords besides the sentiment that is driving that output. What are people talking about? This requires a little bit of tweaking. I don't know if it's going to give us something meaningful, but it essentially will show the most common words across the different articles. And if you're, probably you have to clean up the data before you can. There's some other widgets here that allow you to remove some common words. For example, to, they, you, etc. These are words that are not that meaningful. You can remove from the text without losing the context, right? And then you look at only the words that have some more meaning for you. And you can remove common words in your business that all emails have, for example, to reduce the noise. But it is taking a little bit longer. The other thing here, see this document map? If you're pulling a Twitter feed, the Twitter comes with the latitude and longitude of where the person sending the Twitter is. So you can even visualize on the globe where the tweet is coming from. And if you connect to the sentiment analysis, you can put color shades, red and green on the globe, right? To see the sentiment about your metric, about your brand, for example, coming from the different countries. So I probably got an error here. So let's double click and take a look. And here are some of the topic keywords. So you found 9 topics. I don't think it's that meaningful because I have a bunch of common words mixed together. So this is not that meaningful. I have to click on some options to make it a little bit better, but it will probably take long. This is the pre-processing of the text. If I put this widget here, I can change everything to lowercase, for example, remove accents, remove HTML tags, URLs, remove common words, etc. So it pre-processes the text to remove as much as possible of the noise, right? So you can do all of that here. And, you know, just simple widgets here really embed tons and tons of knowledge and that you would have to spend in order to create these things, right?
This is a definitely very, very powerful tool. Should we open it up for questions? I know we're just right around the time that now for our meetup.
There were a few questions in the one was, how does it work with Tableau, something like this, and there was another question around, can you add additional data sources?
Yeah,
I think it was,
yeah. So here, for example, you have file, right, and you can bring any file from anywhere and load here. Then you can, for Tableau, for example, if you want to export the output to Tableau or to, you know, Power BI, is probably much better than Tableau. There is here save data. So, for example, I can get this data from this output and save somewhere. Right, so I just save as, and the output of my analysis goes to a file that I can load into anything, right? The data sources for text, you can load, you can, for example, put in even in Excel, you can paste the content of emails in the cells, right? By line, you can categorize that, and then you load into the tool here. You have to do some transformations to make sure that is in the right format, but then you simply push that into the sentiment analysis, for example, and boom, there you go. All right. By the way, if you download this tomorrow, one important tip, you go to option and select add-ons. Some of these tools that I use today are add-ons that you need to select here, otherwise you don't see in the menu. So for example, text, textable, image analytics that we saw today, you just click here and it's going to load the libraries, etc. that you need. You can do also geospatial analysis. You can do cell spectroscopy, single cell. You know, you can do biological models and apply. And this is open source, so there's always, you know, new add-ons that people create and add. The other thing that is I think is important to know is that these tools, they generally operate with in a language behind the scenes. So here, for example, going back to exploratory, I can click here and say generate R script, and it creates the code that I can run that will do the same thing. Okay, here in orange, it is Python. So I can add a Python module here, and I can create my own code. It's going to, these lines here become input and output of my script. So I can read the variables, right, from the input, process, and push the output from my script. And it, essentially, if it doesn't have the model that you need, copy and paste from the internet, and boom, you have that model in orange. Same thing with Spotify, but it's with R.
Nice.
Great. Any other questions from the audience?
Yeah, just real quickly, I'm wondering, how do you feel about the security of using something like Orange? I'm looking at their privacy thing. It looks like it's reasonable, but I think you're an expert, so get your opinion.
Yes. So Orange is 100% self-contained. Nothing comes out of the application, right? So this is pretty safe. It's just local, running everything local. In exploratory, you have an option to lock it up, and you instead of a license, you put a license code. So not even to check if you have a license active or not, it goes out on the internet. Or you can even push output to a server, either on the internet or a server that you install locally, and you can create dashboards. So just like with Tableau or Power BI, you can generate visualizations that you can share with the organization as well, right? So, but that depending on the option that you're going to use, some of this data will go to their premise or not. But these two are pretty safe. If you go back to the if I go back to the list of the tools that I have used, oops, something happened here. Can you still see my screen?
Not
No.
anymore.
Okay. So I think I mentioned that some of these tools are on the cloud, right? So you need to have, a compute node on a cloud. So here, Azure, it is 100% on the cloud. So your data is going to be in Azure. Exploratory, like I mentioned, some of the features will be online, but you can lock it up, so it's self-contained. Driverless AI is self-contained. Everything is going, you can install actually in your notebook. It's not going to do much, but it's all in a virtual machine. Orange is self-contained, and Newton is 100% on the cloud. There's nothing on premise, so everything is on their cloud. Actually, this is on Google Cloud, and which would be equivalent to Azure cloud as well. Some details: if you are in government, you mentioned that you are in Washington, DC. Both Microsoft and Google offer a government cloud, which is separated from everything else. It's pretty locked down, even to access the cloud. At Microsoft, for example, we have employees that are especially they have special credentials and background checks, etc., that can manipulate or do anything with their data, right? So it's really high security. But if I had to buy these tools, right, because this is an application that run on my machine, these that run in my machine, not a big issue. just because I had to put this in a virtual machine, I had to go through all the hoops in security at Microsoft in order to gain the okay to actually use this tool. Right. So depending on your organization, you need to go through some security checks.
Great, great. Thank you. If there are no other questions, we can just wrap up. What do you think?
Yeah.
Well, and if anybody wants to go deeper into this, feel free to email me. I'm putting in the chat my email address.
Yeah, that would be great. And they can find you through other social media channels, and Daniel, you as well.
Yep, I'm on LinkedIn. You can find me easily on LinkedIn as well. So yeah, connect and say hello.
Okay, great, great.
Yeah,
Thanks a
thank
lot.
you very much.
All right.
Thank you, guys. Thank you.
Thank you.
Thank
Thank
you.
you. Have a good evening.
All right.
You
too.
Take care.
Bye.
Thank
Cheers.
you.
Bye.
Bye.